So before we start, just to help settle the nerves and warm into it and that, and try and keep it light, tell me the most unusual place you've spent the night. I can start because I dropped the question on you, and intentionally didn't give you time to think about it. Going back about 400 years ago when I was a young fella, we were hunting and we'd shot this fantastic animal, and it was just on dark and we couldn't find it, so we ended up spending the night in the bush and woke up the next morning and it was about 6 metres from where we were. So
very good.
It wasn't planned, but that was pretty unusual.
I flew down to Wellington for 2 days,
right,
and I didn't have any place to stay, so I messaged my mate Ben, who was living in Wellington at the time. He goes, "Yeah, man, you can stay at my flat. It's a great flat, it's just near the Wellington High School."
Right.
And I go there, there's no lock on the door, there's a hole next to the door, the toilet doesn't work, the bath doesn't work, everything in the fridge is mouldy. They set me up on a fold out bed where the front of it doesn't work, so I'm at about this kind of angle.
Yeah, perfect.
And then I think some people started fighting outside the door at about 3 a.m. So the next day I went, okay, look, I'm just going to pay for a hotel. And I texted him and I go, "Mate, I'm not staying another night here. Yeah. Thanks for having me." He's like, "All good, I've moved out today."
You got one, Stephen? Most unusual place you spent the night?
Yeah, we when I was very young, backpacking in Australia, the car broke down on one of the roads, and we went to visit the 12 Apostles. Towards Adelaide or towards Adelaide.
Yep.
And we spent the night with the four of us in a car, and then the next morning we went to this local farm because we didn't want to alarm the people at the middle of the night.
No.
And we got the most beautiful breakfast and reception there, which is till date my favourite experience in Australia. So
fantastic.
Very good.
All those unplanned things, eh?
Yeah. Famous Dutch backpacking.
Nice.
Met my wife there, so that's good.
Yeah.
True. So that's why I'm here.
All right. Kia ora tēnā tātou katoa. My name's Shane Clark, General Manager here at Nuralite. Welcome to webinar 40-something. Today is part 2 of our multi-part series. We're talking about making warm rooms more resilient. And with me on the panel, I've got Peter Mills, who's our in-house Gen Z, who's been at Nuralite for about 8 years now. Is that right?
Yep, 8 years.
Yeah. And what many people probably don't know is that Pete's normally stuck in the office and he does all our interstitial condensation risk analysis. He does all our tapered plans, and we just thought for a treat today we'd wheel him outside, and he can just tell us a little bit about this project that we've worked on. And he's internal technical advisor. Is that right? Is it?
Yeah.
Yeah.
Yep.
Or technical advisor? Or?
We dropped the internal.
Did we? Okay. Because we do take him out sometimes. Also on the panel with me today, I've got Mr. Stephen Van Roon, Director from Samson. Welcome.
Thank you.
You've been there some time now, some 20-odd years?
23 years, yep.
Nice. So those of you who don't know, Samson is our favourite Nuralite applicator today. And for the last, 30 years, Samson's been an installer of Nuralite products and systems, and obviously instrumental in the project we're going to be talking about today, and obviously the instances we're talking about how we make warm rooms more resilient. All right, so this webinar is set for 30 minutes. Even though we're here with our friends today at PodLab, this is a webinar, so I understand the difference is that the webinar is interactive. So you'll see at the bottom of your screen there's a Q&A function, so feel free to drop some questions in, and at the end of the prezzo we'll run through the Q&A and give you some of the answers. If we don't get through all the questions, that's fine. Everyone who registers today will get sent out a pack with all the answers typed into a document there. So if we don't get to your question, we'll get back to you. There's also a couple of polls towards the end to keep it all interactive. And today's topic is just an extension of making warm rooms more resilient. Warm rooms are a thing. You would have seen it in your experience. Like we all started off, we go back to however long ago, we were talking single layer membranes on plywood, and that was called a roof. We've now, we then sort of evolved to 2 layers of membrane, and now we've evolved to this layer of insulation on top. So if you're not sure what a warm roof is, if you want to flick back to the first part of the webinar, we ran through that and did a bit of an overview of what a warm roof was. For us, you probably would have seen it, Pete, in your 8 years as well, that it's now a big part of our business.
Yeah, about 50% probably.
Yeah. So when I was there like 10 years ago, 5% of the roofs were warm roofs.
Yeah.
We were pushing them hard, and we're just seeing that they're a big part of our business. And you've probably installed more warm roofs now than cold roofs is becoming part of your business.
Not quite yet, but we're getting there. It's the last 10 years it's taken off really well.
Big take up. Yeah, right. And the reason for that is a couple of reasons. People are demanding better performing buildings. Around thermal envelope and things like that. Latest changes to H1 in the building code. Do need to increase R values, and the only sensible way to do it is to put the insulation on the outside of the structure. Warm roofs have been a big uptake in our business, so important to make them more resilient.
Well, because we've been making learnings as we're going along, right?
Yep.
When we were going from 1 layer to 2 layer, there's takeaways from what you can and can't do there.
Yep.
For instance, like cutting triangles out of one of your layers.
Yep.
But also warm roofs being so different, there's a lot of hidden things that we've picked up on the way.
Yep.
And I think a lot of that is coming through to this webinar.
Exactly. So we can bulletproof. So today's webinar is important to you as an architect, designer, builder. We assume that's who's here. And Mum, hi Mum. So MB are planning some significant changes around legislation to designers. We're moving from sort of just a simple joint and several liability, changes around professional indemnity insurance. It's going to be even more expensive to become a registered architect. So we think this is why this topic today around increasing the resilience of your warm roof is important to you guys. All right, so I guess the whole conversation is going to orbit around this one key message, right? So is that Nuralite can de-risk your warm roof. The last webinar we talked about the types of insulation. We also talked about fixing types and electronic leak detection. So we don't need to cover any of that today. We've done that in the last one. Today we're going to talk about compartmentalization or night joins of the warm roof. We're also going to talk about outlets in the substrate, which is an evolution, I guess, an addition. We're always trying to continually improve what we're doing. Yep. And we're also going to touch on how to create bulletproof penetrations. So the project is, it's a Fisher & Paykel building. It's called the Home Office, is it?
So it's a Fisher & Paykel Appliances headquarters. Okay. And it has 3 sections, I presume. Right. The garage building, the shed building, and the home building. And we installed about 6,000 square meters of warm roof to the shed and the home building.
Okay.
So quite a
substantial size, and it's in Auckland, right?
It's Great South Road.
Great South Road. So they give people a bit of a geo-location sort of vibe where it's at. Yep. So that's the project. Is it finished? No, actually, you're getting a bit of a sneak peek at the project actually, because it hasn't been officially opened yet. So
correct.
You can have that for free. I guess one of the unique things to me, just go back to that previous slide, this one here. One of the unique things about this building is it's made from timber.
Timber
completely made from timber,
Yeah, timber cross laminated, 3 stories, and the biggest building of its kind in New Zealand at the moment. So quite a special building.
And you worked on the previous largest mass timber construction, was the City Mission home ground.
Auckland City Mission had a similar design,
Yeah, so all the floor slabs, in this instance, when I say mass timber, it's all CLT, so cross-laminated timber. Quite a unique building.
Absolutely.
Quite a great job.
It's so cool to walk through. I can't imagine how good it looks now that it's actually just about finished.
Yeah. Cool. All right, so that's the project. We go to the next slide, which we're going to, this picture might not look like much, but
aren't you guys excited looking at this photo?
Yeah, I'm revved up, mate.
Wow.
This is not a photo you typically see on a website.
No, you don't.
It's not you're not going to put it on a brochure or anything like that. But
it's a real action shot.
It's an action shot.
Yeah.
It's
we know you like seeing the real stuff.
Yeah. It's the real deal. It's kind of like a behind the scenes vibe. Yeah. So the first point we're talking to today is about compartmentalization or night joins of the warm roof. So Stephen, you just want to try and sort of talk through what we're looking at here in the layers if we step through the build-up.
So on the right side, you see the vapor barrier. That was, in this case, also installed before we came on site by the manufacturers. You guys had a role to play there. And it gave the main contractor some weather tightness during construction. We had no shrink wrap structure or anything like that.
Oh, okay.
To protect us from the weather.
Yep.
So this was the next best thing to do. So you see the vapor barrier on the right, and then you see the build-up on the left side of the PIR. And the night joins are a necessity that every day we close up a section that we completed.
Yep.
And by doing so, you create these night joints, which is a vapor barrier going up and over the upstand of the PIR boards.
Yeah, so if you could just see that little step there between what's the lowest level and then up to the insulation level, you can sort of see that.
All of these challenges are pretty much present because of the lack of shrink wrap, right?
Yeah,
I feel like that's a very large foreground element to this project.
Whether it's shrink wrap or not, you should still seal it off and compartmentalise your roof.
Yeah, correct. That is true. But we would, in every proposal we send out, we emphasize the importance of a watertight structure, like a shrink wrap structure in place to allow us, because it's quite critical to the success of a warm roof.
Absolutely.
And these night joints are a necessity, but it also turns into a quality assurance.
Yeah, it does.
Well, it's a bit like if you could do something easier and just be a little bit more sure that it's going to be watertight, why wouldn't you do it? So it's like, it makes sense to try and advocate for a shrink wrap wherever possible.
Yeah, and we see clients already talking about it as part of the QA, so it is good to get them installed and compartmentalized.
So just on the slide here, we're going to show a two-dimensional detail of the previous photo, if you'd like to try and help explain it. So Pete is clever enough to have drawn this detail, so I'm going to let him talk about it.
Well, I didn't draw this detail. My friend Franz drew this detail. But what we're looking at here is a substrate with some primer in orange. I think that's orange.
Yep.
The vapor barrier layer that was installed in the factory at Red Stag.
Yep.
Then we've got our PIR board and a fixing going through it. And then finally, the last green line that's in a Z shape is the night join strip of vapor barrier that's going over the PIR and the original.
So the next stage in the night join here.
Yep. So that's our Nuralite base sheet.
Yep.
Being brought over most of the PIR and being loose laid effectively over the strip of the vapor barrier. So it's being used effectively as a tarp in this case.
As long as that front edge is sealed off, eh?
Yeah, for the night.
Yep. And then we can see the final step.
Yeah, so this is the completed roof.
Yeah.
The night join has been covered over with more PIR. The base sheet that was previously loose laid has had the film removed and has been rolled over the total surface so that it's properly waterproof in its own right. And then the blue layer at the very top is our second layer, our cap layer of Nuralite 3PM. So that's a finished roof at that point.
Nice. So if we just throw back to that photo, which I think is the next slide, hopefully that sort of explains what we're talking about, right?
Yeah, this is effectively photo 2.
Yep.
Where the base sheet is being used as a tarp. It's just that in this photo it hasn't been fully rolled over because they're still working on it.
Well, it's an action shot, right? I mean, if it was a GIF or something like that, you'd see the next step and the next step.
Yeah,
right?
well, when we show up on site, we don't go, "Hey guys, we need a perfectly," we're thinking about this for a webinar in 12 months to make sure it's staged.
No,
this isn't even our photo. This is your photo, Stephen.
Yeah, correct.
One of the QA photos, right? And it shows.
Well, it does form part of the QA.
It shows in the layout where the compartments are and whatnot.
Yeah.
Okay, I just want someone to talk about the compartmentalisation, and if you do get, I want to try and cover it somehow. If you do get like post-trade damage or something like that, and it's compartmentalised, you can electronically leak test that particular part, if you know what I mean.
Yeah. Well, I mean, in this case, the night joins are incidental, but you can deliberately do these, and when you're arranging the night joins in this way, it turns into compartmentalization. And in that regard, if you, for instance, put a night join around an outlet or a pipe penetration, and then that ends up failing, then the moisture ingress is limited to that area.
Yep.
But you can leverage that to make sure that the whole roof doesn't end up being a problem.
So on a large roof like this, was it 6,000 square metres?
Yeah.
If there was some post-trade damage, skip bins or scaffold poles, or which is quite common, unfortunately. You'd be able to, if it's compartmentalised, you could obviously localise any damages, and you could track it using your electronic leak detection.
Yeah, absolutely. Yeah, and because if you don't have them in place and water gets under, they can travel freely.
Yeah, that's right.
The damage could be enormous.
Could be anywhere. And pretty important in a 6,000 square metre roof.
Yeah,
right.
Absolutely.
Just want to touch on one of the highlights that we kind of mentioned, what I quite like, is that the timber was supplied by Red Stag out of Rotorua. So the panels, which are 180 mil thick and X amount of metres long and whatnot, they were pre-manufactured in Rotorua, and the vape barrier was installed there, so they were able to be trucked to site to keep weatherproof. So I think it's a pretty unique solution for a job like this, right?
And when we came to site, we fixed some of the mechanical damage that happens. But it was an easy fix, and it was a good, all in all, good system to provide the client with some weather tightness during construction.
So probably a good time to shout out to the good people at Naylor Love, RTA Studios, yourselves. They all sort of jumped on board and problem solved all the way through.
That's good.
Pete, you're involved with this building. Like, I was probably going back as far as 2 years ago as part of the design. Yeah. So it's a long road, and it's really good to be involved early on.
Early contractor involvement is, I think, crucial to the success of.
Absolutely, especially for a complex roof like this.
Yeah, absolutely.
So this is the photo here. What we're looking at is, I guess, the stage 2 of that night joint. So we've lapped the base sheet down over the joint, which is a great segue, because right in the front of that photo there, we can see, I guess we'd call it an outlet in the substrate. It's actually part of the siphonic drainage system for this job. But it sort of segues us into that next piece around outlets in the substrate. So again, it's an evolution of what we're doing. So what are we trying to achieve by putting an outlet in the substrate there, Pete?
Well, in the event that someone does damage the membrane and there is failure and moisture ingress into the warm roof system, we want to be able to take that moisture away without removing the entire system. The best way to do that is with an outlet. And
I guess from your point of view, is trying to install the roof, this building wasn't shrink wrapped or anything like that because it's far too big.
No, usually you need drainage during construction. So with the vapor barrier, you can trap the moisture in there, and you can build like a swimming pool on the roof. So you need drainage in place, whether it's permanently or temporarily. And whether you get any damaged membrane during construction or afterwards, having an outlet in the substrate just gives you guidance if water's coming through there or not, and whether there's water coming in, because it's really hard to detect once it's in there. It's almost impossible to detect until somewhere starts leaking or you get water out of the outlets.
And I could be wrong here, but a lot of concrete construction, you end up creating like an area for the warm roof that's a bit like a bathtub, and they'll cast PVC pipes into it. But there's an argument to be made that you could cast one of these outlets in there instead.
Absolutely.
Do the same job. Just cordon would work, Here's another detail that Peter didn't draw. You want to tell us a little bit about it, mate?
Yeah, so on the left side of this drawing, we have a Aquanite clamping type outlet. Holding it in my hand here.
Nice.
Consists of a PVC kind of, what is this called, a moulding, a drain?
Sure.
And then it has these brass lugs in it that this clamp ring is supposed to sit on. The membrane goes between these two, and then this ring effectively holds it in place. In the drawing there, that is the blue line. And then the top kind of crown-looking thing is the clamp, along with this dome grate here. So these work together to effectively restrain the membrane, make sure that it's waterproof long term.
And what have we got going on in the right-hand side?
So that's effectively the same outlet, but with a flat top on it instead of one of these kind of crowny leaf guards. And the reason why it's flat is so that all the other elements can just sit on top of it unobtrusively.
So in this example, in this detail, we've kept off the bottom of the outlet, because it's got to be sealed up, of course, because it's clamped into the vapor barrier. I mean, that's just one option. I've seen other options where it's plumbed into an indicator, so it's actually like a clear pipe, and it's hanging down in one of the maintenance rooms or whatever, and it's sealed again, but it's a clear pipe, and you can actually see if there's moisture in it as an indicator.
Connected to the stormwater.
Yeah, or connected to the external plumbing. So, so that sort of rounds off sort of the outlets and the substrate, and why that's a great evolution and a good idea to add that additional layer of redundancy to your warm roof build-up.
Yeah.
Just going to go on to the next slide now, and we're talking about bulletproof penetrations.
Not actually bulletproof. Don't fire bullets at these.
Right. Sorry, it's a poor dad joke. It's all I've got. So, in a perfect world, Stephen would have a finished membrane roof, and no one would walk on it ever, and no one would put anything on it, and you'd sleep a lot better at night, wouldn't you?
Absolutely, for the next 20 years. Yeah.
Unfortunately, that's not what happens, is it?
No, it's not. But these Nuralite plates are really good.
Yeah.
And we've installed just under 1,000 of these at Fish and Pike Appliances headquarters.
It's amazing.
On the roof.
Yeah.
So we're well versed of how they work, but they're very good for the design.
Yeah, cool. So what we're looking at here on the screen is a 2D detail of our Nuralite fixing plate. We're going to show you soon a quick install video.
Well, we should probably talk about why it's important, right? Because to a lot of people, this is just going to look like a bit of membrane and a what's it called?
Well, we've had this is not quite the same, but with roof anchors installed, especially for forced drain systems.
Yep.
They are renowned to allow water in.
They are.
Right, and these penetrations. And so I think with these fixings, even though it's for the solar panels, it's really important that they don't directly penetrate into a warm roof, and that you got the cover of the membrane on top, and the tape or the back barrier patches.
I guess for people that don't know how these work, there is obviously the underside of the plate.
Yep.
There's the membrane that goes over the whole thing, and then that kind of stainless steel puck at the top actually clamps down on the membrane, very similar to this outlet, and has a bead of sealant as well.
Yeah, so these are a factory-made unit, basically, that are just lifted and dropped onto your roof and give you that assurance of a watertight penetration.
To protect the membrane. And the integrity of the warm roof system, for example, where if you get other contractors coming up with their ideas, it doesn't often comply with what we call a weather tightness.
Exactly. Yeah. So what we're going to do now, rather than us talk about it, we're just going to show a video of how a fixing plate's installed.
So that's our fixing plate here, same as the one in front of us.
Yep. So these guys are measuring it out far too accurately for a demonstration, but that's fantastic. So we've basically what we're looking at is a finished warm roof. It's all done and dusted. They're going to come along now and put some holes in your perfectly well installed membrane. Yep. And this is probably, in our opinion, the best way to create a penetration. So they're marking out the plate now and putting in the blue thermal flanges. Now, we talked about this in the last webinar. You guys weren't here, but that's all right, I was. It sort of maintains that continuity of the thermal envelope. In this example here, we're using 4 fixings per the plate. So the plate allows up to 8 fixings, all depending on the engineering required, whether we need 5 kPa uplift or whatever we're trying to achieve. So in this example here, we're just using 4 fixings.
Generally, you'll want to use all 8 fixings because why wouldn't you try and get the most out of the thing?
Well, yeah, I mean, the more fixings you use is actually the less plates you need.
Yeah.
So it comes down to engineering.
Yeah.
So we've marked out the plate. We've pre-installed the holes for the fixings. We're now using the Nuralite sealant to the inside of the plate, which forms a seal between the underside of the steel plate, coated steel plate, and the top of the membrane. So that's just placed into that wet sealant.
And
another line of defence.
Yeah, absolutely. The fixings, these are the thermal flanges that are then installed. They don't normally work this fast, thanks to the wonders of television. We've sped this up.
Yeah, it's good productivity.
With double speed and portrait mode for all of the short form content watchers.
So this is all supplied as a system, right? So it's the plate, the thermal flange, the right fixings for the substrate, just to guarantee, compliance and continuity with the whole waterproofing system. We're using a nice, easy timber substrate like you guys had.
They're doing well.
Yeah. Big shout out to Rod and Steve for putting this plate in for us. They're not Nuralite applicators, but they're wonderful people we have.
If they ever look for a job, or
exactly.
They can apply with sensing.
Exactly. So here we're using a little piece of the vapor barrier just to cover up that fixing. Again, another layer of redundancy built into the penetrations. It's probably the most important part of the roof. Like the membrane itself's factory made, so it's usually free from issues. You guys install it on a nice flat surface. It's only when it comes to the penetrations it's the difficult part.
I guess the benefit of having the sealant underneath and the tape on top provides as much of a barrier as you possibly can if the actual torching that they're doing here ends up failing.
So here you've seen the example here. We're using this is part of the application process of a normal torch on membrane. We're using the same tools and techniques and whatnot to actually install the factory-made skirt onto the membrane roof. So once that plate's installed, you're free to pretty much install whatever you need. So we'll leave an M10 threaded slot on top of the puck, and then from there you can fit whatever you need. So in this instance, we're just using a solar panel cleat for a rail. So
often gets used for HVAC equipment. Aluminium deck rails will use this to ground themselves. The only thing it can't do is things like abseiling. There is an engineering limitation to it for that massive force. So if you just quickly flick back to that two-dimensional detail, we should just round out quickly what we talked about. So that was a video of that installed, how we create a bulletproof penetration. So a 6,000 square metre roof, I don't know if anyone would guess how many penetrations it had, but how many of these plates did we put on?
So we're just under 1,000, 980 we installed. In addition to that, we had hundreds of other penetrations for fencing and services. So, you're right. As a waterproofer, we'd like to see no penetrations whatsoever. But this is all part of what the reality is. And so these plates have been great. It gives us confidence around the water tightness around these penetrations. So it was a lot of work.
Absolutely.
Some of the photos we'll show later on.
So from this point, we're just going to jump into a photo montage and talk about, again, back to the Fisher and Paykel project and talk about the three instances that are actually used on the roof. So look at this slide here. It wasn't just the fixing plates you had to deal with as a penetration. You had your normal pipes and whatnot to deal with as well.
Service pipes. Here you can see the solar panel brackets getting installed.
So that's just some of the 1,000 or so that you installed?
980, just under 1,000.
So it's a salesman and me just rounding everything up. Sorry.
Fair enough.
And I'm not very good at maths, so just round it all up. So what are we looking at here, Stephen? Part of the roof?
So we're seeing the solar panels being installed on top of the framing, which is installed on top of the Nuralite fixings. Just under 1,000 of those that we installed, and you can see the whole roof is covered with solar panels, which is really good for the Green Star rating, which is part of the client's requirements.
There's solar panels all over that place, eh?
It's
Eagle Eye Pete, you've spotted something there?
It's important to note that there's some different coloured membrane rolls rolled out strategically around the solar panel array. The idea behind these is that is a walkway. If you're directing people on where to go in a direction that's sensible, they'll walk on that wear layer, and that potentially protects the roof.
So it's an additional layer, is it?
All right. Sacrificial
layer. That's a good idea. That's another way to make your warm roof robust. That actually wasn't on the list of 3, so you got a 4th one slipped in there 4 for points. Free. Well done.
It's quite good because double layer bitumen membrane is the strongest out there on the market, and an additional protection layer for service traffic. It's a good idea.
All right, let's go to the next photo. So this is obviously an aerial view, more of solar panels installed there. Gee whiz, there was a couple of solar panels on that job. A couple more plates. So it wasn't, these penetrations are a bit more heavy duty, aren't they? So we talked about fixing plates for solar panels on that. And what were these ones for?
So these are for the full restraint system. And also in previous photos you saw some of the other plant, and they got some fencing around as well in the background here. So again, good details, good design, and it's crucial with warm roofs to have these installed prior to installing the warm roof. It allows us to detail them properly. To try and do this retrospectively is quite challenging. So that's all well organised by the main contractor.
Fantastic. And again, what I like about these photos, these are actual site photos. You won't see them on a brochure, you won't see them on the website, but it does give you a bit of a behind-the-scenes view of what goes into it, All right. Looks like getting near completion. So,
and here's the building, which is a beautiful structure.
Pete, do you want to tell us a bit about this? You were very heavily involved in designing the tapered layout for this particular roof. Yeah. So not only was it big, it was also
complex,
crazy shape.
Yeah, this roof is a bit of a monster in terms of tapered design. What you're looking at just looks like a snake, but when you zoom any part of this roof in, it's several hundred square metres a piece. We had to break this down into 8 sections. So each time there was a curve or a length, we had to cut that into a piece and just consider that as its own roof. Fortunately, there were actual block lines to delineate these roofs. But it's by far the biggest roof we've ever had to do a tapered plan for.
Fantastic outcome. So that was our roundup of the Fisher and Paykel project. We talked about compartmentalisation, we talked about outlets in the substrate, creating bulletproof penetrations, all ways to sort of de-risk your warm roof and make them more and more robust. Reminder to chuck in your questions in the Q&A section at the bottom. Also, being kindly reminded that this presentation is NZIA CPD accredited for 5 points. So at the end of this, there'll be a quick survey that goes out, and you'll be able to fill in your little NZIA number and get your points. Like all our webinars, if you go back to our website there's 50 plus something webinars there to get your CPD points.
Talking about CPD points, we've got our Nuralite Roadshow coming up. Auckland, Christchurch, Queenstown, Wellington. You've got a reason to be there now that we've got 15 points, so please get your tickets.
And welcome to the Q&A. Well done. Just before we jump into the Q&A, I see there's a few questions in the Q&A section. That's great. I'm just going to run a quick poll. So of the 3 de-risking strategies we've run through today, which one resonated with you the most? So if you guys just want to pop that poll up for a couple of seconds, and we'll see what the results are. Give the folks at home a second to fill in the form.
Keen to see the answer.
Yeah, I think we can show the results. Nice. Good to know.
Cool.
All right, the first question we've got come in is, do you have a TPO warm roof solution? This roof's obviously about torch on and stuff. Do we have a TPO?
Yep, we've got a TPO warm roof. We've worked hard on the system. It's code mark certified.
Yep.
We've got a suite of details for it. Yeah,
cool.
Works just as effectively.
I think this kind of links into it. This question here, is the fixing plate available on the TPO as well?
Yep, that's part of that hard work. Is we've got an accessory for the TPO that's the exact same as this.
Nice. Question probably for Stephen as the contractor there. How does compartmentalisation or night joins work with electronic leak detection?
So when you test it for the quality assurance of the membrane, if in case you do find a breach, then these compartmentalized sections are easy to identify, and they protect the remainder of the roof from further water ingress. So it's pretty easy to do. Nice.
So is there any additional cost for the compartmentalisation part of the project?
No, they're part of the QA, and they have to happen every day.
Right.
Regardless, even with weather protection in place.
Yep.
It's the right thing to do every night to close it up.
If I remember correctly, Pete, I think it's actually part of our standard spec. Like it comes with it, like to create a night joint.
It's in there.
Yeah. Cool. All right. Here's one question around about, again, electronic leak detection. Do you put mesh on top of the system?
Yeah, there's different options, a mesh or a ribbon that you can install nowadays, and that allows us to test it.
And just Pete, with the Neuratherm roof, do we need the mesh, or can we do it?
Well, our spec just has a conductive tape in between the board joins. There's nothing stopping you from adding to that and doing the mesh as well, but as the basic version of it, we just have a tape and an earthing plate.
Cool. Right, got a few questions here. It's great to see. Let's go through a few. There's one about the detail. Actually, we showed the outlet detail up on the screen there, showing the outlet in the substrate and the roofing substrate. That particular detail is not a standard detail. That was actually us working with a facade engineer on a specific CLT project where they wanted to include a void on the underside of the insulation. So it's not a standard detail, but we're able to produce job-specific details depending on who needs what. So hopefully that answers that question. Also back to that detail, the roof dropper is installed on timber blocking, ? So
yes, that or in the substrate itself, but we can't install them on the PAR boards themselves. Just not strong enough to, if somebody stands on it or it gets damaged.
And people do stand on them. They're like a magnet, right?
Unfortunately, they do. Yeah, they're a target.
Yeah, they are. So yeah, I mean the PAR board's got a compressor strength of 175 kPa or something like that, which is good on the flat, but when you point load it, so yeah, we're timber blocking all the outlets. Let's have a look. Some good questions here. Like I said earlier, if we don't get through all the questions, they'll all come through in the webinar pack where we when we send it out. What percentage of the roofs that we do are green roofs?
Very, very small percentage.
Yeah, too small.
Too small, yeah, good answer.
But of green roofs, I'd say the majority of them are warm roofs.
Yep.
And that's owing to the fact that if you're not insulating the green roof, it's hard to ventilate the underside of it.
Yep.
So there tends to be a pragmatic decision to just make that a warm roof.
Yep. So we've done a few green roofs, but
few and far between.
Yeah.
I think there's
single
be more
digits.
encouragement from the government or local councils to encourage that more. I think.
Yeah, I mean, there's many reasons to love a green roof, and everyone's got their reasons. From our point of view, we love it because it covers up the membrane, protects it. It's never going to see the light of day. It's going to be a lot longer longevity, you know.
Yeah.
So, right, what else have we got here? Sorry. So we again back to that outlet in the substrate here. There's a question around about while it's good to let moisture out, but won't it let moisture in? One thing that may have sort of stepped over is that it would be a reminder that's capped off, isn't it? It's sealed. Yeah.
So when we were looking at these, we were proposing doing just a welded cap to the bottom, and then there were some versions that had a little inspection hose to check whether there is moisture coming through it. But yeah, no, you don't want to let vapour into the roof assembly.
Yep, so it's got to be sealed off. All right, we've taken up plenty of your time. We appreciate your viewership. Thanks very much to those that attended. Appreciate the Q&A and your input into the polls. That's great. Special thanks to our panellists, Mr. Stephen Van Roon from Samson. Thank you.
Thank you.
And Peter, thanks for being here, mate.
Thanks, Shane.
Not that you had much of a choice. It's great. Great to see you here.
Happy to be here.
So just before we go, there's one final poll. If you're working on a project at the moment and you'd like someone from the team to reach out, and we can help you out with that, just sing out. And the NZIA survey for your points will come out automatically at the end of this if you stay on your browser. Otherwise, flick us an email. And we'll see you on the next webinar. Ka kite anō. Thank you.
See ya.
See ya.